For the functions f of x equals 3 to the x and h of x equals 3x plus 3, examine the table of the linear and exponential functions below. Which of the following statements are true about the functions? Select all that apply. Let's first take a look at how each of these functions is behaving. F of x equals 3 to the x is our exponential function, and h of x equals 3x plus 3 is our linear function. Our exponential function in the beginning, between -4 and -2, grows very slowly, less than 1 unit of growth. Even between -2 and 0, it still grows less than 1 unit of growth. Then all of a sudden, between 0 and 1, it grows by 2 units of growth. And now, all of a sudden, between 1 and 4, it jumps a huge amount and has grown by 78 units of growth. Let's look at what happens to our linear function. Between x equals -4 and -2, it grew by much more than the exponential did. It grew by 6 units. Then between -2 and 0, it grows by another 6 units, grows by 3 units between 0 and 1, and another 12 units between 1 and 4. So it started off growing a lot faster than did our exponential function, but ultimately the exponential function, because you're multiplying amounts over and over and over again, you're multiplying larger and larger amounts by themselves in an exponential function, eventually our exponential function will always grow much faster than a linear function will. And you can see that in this table. So if you look at our options over here at x equals 0, h of x, our linear function, is still greater than our exponential function. At x equals 2, which is going to be somewhere between 1 and 4, f of x and h of x are equal. Well, we don't have a table value for that, but we can plug it into these equations and see. At 2, e is going to equal 9. Our exponential function is going to equal 9. F of x is going to equal 9. And at 2, our linear function is also going to equal 9. So yes, these two are equal to each other at x equals 2. At x equals 3, f of x is greater than h of x. Well, we know that at x equals 2, our functions were equal to each other, and we know that in the long run, like even by x equals 4, our exponential is going to be greater than our linear. So since x equals 3 is after this solution point over here, we can make a pretty solid guess that at x equals 3, f of x, our exponential function, will have outgrown our linear function. At x equals 4, h of x is greater than f of x. That is not true. At x equals 4, h of x is much smaller than our f of x.